Hello, my dear ninth standard students. Welcome to lecture number 8 on motion in our YouTube channel. This is RV Jambagi. In the previous period, we studied few more problems on speed along with uniform and non-uniform speeds and the part of velocity. Let us continue the same concept of velocity first, and later we will take average velocity, uniform and non-uniform velocities respectively. Velocity of an object or a body can be changed by changing its speed. You can change the speed of the object or a body, or in other words, you can change the magnitude of the body, direction of motion of the body, direction of motion of the object, you can change direction of motion and you can change both. So velocity of an object can be changed by changing its speed, direction and both. Okay, so to understand this statement, let us assume a car is moving on a road of a city where it enters the region of traffic. Okay, you can imagine a car is moving on the road of a city where it enters the region of traffic. It is obvious that driver should vary the speed. It is very much obvious that driver should vary the speed, which means he or she changes the magnitude of velocity. So the change occur in the speed or magnitude of the velocity. In the second case, assume the same car leaves the city. In the second case, the same car leaves the city and finds the circular or curved path. Okay, it is finding the circular or curved path. In moving so, it changes its direction. In moving so, it changes its direction. That also affects the velocity of it. Note that both changes may occur simultaneously. Both changes mean you can change the speed or magnitude and direction of motion of the car. Okay, so you can conclude from these examples that velocity can be changed by changing its magnitude or speed, direction or both. Let us take the next part, that is average velocity. We have two definitions here. So let me take the first definition and later we will take the second one. Okay. So first definition says that the ratio of total displacement of an object, the ratio of total displacement of an object to the total time taken by it, to the total time taken by the object is known as its average velocity. Okay. The ratio of total displacement of an object to the total time taken by the body or an object is known to be as average velocity of it. It can be written mathematically as average velocity is equal to total displacement divided by total time taken. So here also you can take VAV, the average velocity, which is equal to total displacement. I took for the total displacement as x and total time taken, that is again t, and hence average velocity VAV is equal to x by t. So this is the first definition. Let us take the simple example for this. Consider a body is moving along a straight line AD Consider a body is moving along the straight line A to D, that is simply taken as AD, traveling 16-meter distance in first second. I'll take that point as B, and 9 meter in the next second, that is at point C, and finally 20 meter in the third second. Okay, so this is the path in which the body is moving. Let us imagine that the object is moving in that direction. Okay, so the total displacement of the body can be calculated as, that is the 45 meter. How? Initially we have the distance from A to B, A to B first, later B to C, then C to D. So for the first second, the body is traveling how much? That is 16 meter, then B to C, that is 9 meter, and finally in the third second, that is 20 meter. Okay, let us add those. For calculating the displacement, add them, because the direction is clear here, it is along AD. Therefore, the total displacement will be AB plus BC plus CD. Therefore, 16 meter plus 9 meter plus 20 meter, that gives you the total displacement of 45 meter. And the total time taken for the first second, for the second second, and for the third second, therefore that is total time is simply 3 seconds, and hence the average velocity VAV can be calculated by 45 meter divided by 3 seconds, which is equal to 15 meter per second along with the direction AD. Okay, the average velocity of the body which is moving along the direction AD, that is simply 15 meter per second. When a body is moving along a straight line, at variable speed, when the body is moving in a straight line at variable speed, we can also express its magnitude in terms of average velocity. We can also express the magnitude of it is in terms of average velocity. The second definition, the arithmetic mean of initial and final velocities of the body for a given period of time is also called as average velocity. The arithmetic mean of initial and final velocity of a body for a given period of time is also taken as average velocity. Assume a body or any object which is moving in certain direction. Initially it is moving with some speed or velocity, that you have to note it down, that is taken as initial velocity, and later it gains some amount of velocity more, you take it as final velocity V, and hence you can take their initial and final points of velocities for a given period of time, and hence you can write it as average velocity is equal to initial velocity plus final velocity divided by 2, and hence VAV in other form it can be written as U initial velocity plus V final velocity divided by 2. That is the arithmetic mean of initial and final velocities of the body for a given period of time. It is taken as average velocity. For that, let me take a simple example. A body which is moving in a direction A to B, or it is moving along AB. Initially, it has a 10 kilometer per hour speed. The magnitude of velocity is also taken as speed, I already mentioned. So that is 10 kilometer per hour, and finally it gains the velocity at point B, that is 50 kilometer per hour. Therefore, average velocities should be initial velocity, that is 10 kmph, plus final velocity 50 kmph divided by 2. Then the average velocity VAV can be written as U plus V divided by 2, which is equal to initial velocity is 10 km per hour and final velocity is 50 km per hour divided by 2. That gives you 60 kmph divided by 2, and hence the average velocity is found to be 30 km per hour. Note also that here average velocity of a moving body may be equal to 0. This is very much important at this note. Average velocity of a moving body may be equal to 0. Average velocity may be 0, but average speed cannot be 0. Average speed cannot be 0, because to give the clarification, take the example here. The average velocity of an athlete completing one round while running on a circular track. Average velocity of an athlete completing one round while running on a circular track. If athlete is try to move from point A in a circular path and coming back to the point A, in that case the average velocity of that athlete is taken as 0, since he is returning to the same point, though his average speed is not 0. Average velocity of an athlete completing one round while running on a circular track is 0. Average velocity of him is 0, but average speed is always counting. Okay, average speed cannot be 0. I hope you got the concept of average velocity right. Let me take the next concept, that is uniform and non-uniform velocities. Motion of any object may be uniform or non-uniform or variable. Motion of a body or an object may be uniform or non-uniform. Therefore, we have the definitions of uniform and non-uniform velocities. An object or a body is said to be moving with uniform velocity. An object or a body is said to be moving with uniform velocity if it undergoes equal displacements in equal intervals of time. If the body undergoes equal displacements in equal time intervals, then such velocity of the body is taken as uniform velocity. I hope you got the definition clear. Examples for uniform velocity. Rotational speed of the earth. Rotational speed of the earth is taken as an example for uniform velocity. Earth is rotating around some amount of speed in particular direction. West to east in particular direction means it is rotating around itself from west to east with some equal speed, and hence you can call it as uniform velocity. And another example here, a car is moving on a straight road in a particular direction. A car moving on a straight road in a particular direction if it is maintaining equal displacements with time with respect to equal intervals of time, then the motion of the car is the example for uniform velocity too. I hope you got the examples clear. Let me take the next part, that is non-uniform or variable velocity. An object or a body is said to be moving with non-uniform velocity or variable velocity if it undergoes unequal displacements in equal intervals of time. It goes unequal displacements, the body goes unequal displacements in equal intervals of time, or you may change equal displacements in unequal intervals of time too. No problem for that. Any one of that varies, then it will be variable velocity or non-uniform velocity. Velocity is said to be variable if there is change either in magnitude or its direction. Velocity of a body is said to be variable if it changes its magnitude or its direction. Okay. Examples for non-uniform velocity. A car is moving in a north direction with different speeds. A car is moving in a north, that is a particular direction, with different speeds. In the previous example, we took with a constant speeds, here with the different speeds. An object moving along a circular path. An object is moving along the circular path. In that path, the direction is always changing, and hence it is also taken as non-uniform velocity. The velocity of that object is taken as non-uniform or variable velocity. Dear students, I hope you got all the points which I discussed in this period clear. This ends today's lecture on motion. Dear students, I will meet you with some more videos in the next week. Till then, take care of yourselves. Bye-bye.